Okay, so you have to primarily understand the value of M. How do I calculate? So M is the ratio of mass of the steam bleeded to the mass of the steam entering the turbine. Let us understand what is this. Suppose, please understand my examples. This is very important to be understood. Okay, suppose 10 kg per second of steam is entering the turbine. Out of 10 kg per second, I would send 2 kg per second back to the regeneration process, which is the mass of the steam bleeded. Now, can I have the value of M? So, what does the value of M says? It is the mass of the steam bleeded in the sense sent back for the regeneration, okay, to the mass of the steam entering the turbine. Now, can I have the value of M? Anyone?
By
So, how did you calculate it?
10 by 2.
What is 10 and what is 2? Be fast, be fast. What is 10?
Quantity of steam bleeded.
Huh?
Steam bleeded.
ಆದಿತ್ಯ ಗಟ್ಟಿಗೆ ಮಾತಾಡು, ಕೇಳ್ತಾ ಇಲ್ಲ.
Quantity of steam bleeded.
ಯಾವುದು 10?
Ah.
ಮತ್ತೆ 2 ಎಂತ?
2 quantity of steam bleeded, sir.
ಕರೆಕ್ಟಾ? ಬ್ಲೀಡೆಡ್ ಯಾವುದು? 2. ಎಂಟರಿಂಗ್ ದ ಸ್ಟೀಮ್ ಟರ್ಬೈನ್ ಯಾವುದು? 10. ಸೊ ಈಗ ಹೇಳು ವ್ಯಾಲ್ಯೂ ಕರೆಕ್ಟ್ ಆಗಿ. ಎಂ ವ್ಯಾಲ್ಯೂ ಎಂತ ಆಗ್ತದೆ ಅಂತ.
.2.
Okay, understood everyone? How do I calculate the value of M?
Yes, sir.
Everyone?
Yes, sir.
Hashir, so what is M? Hashir Sayed?
Yes, sir.
So what is M? How do you calculate it? It is the ratio of
Sir, M is mass flow rate, no, sir?
yes, it is mass flow rate, but we will be indicating it in this way in the regeneration. Okay, so in regeneration, if you want to calculate the value of M, you are supposed to do it as such. For example, is equal to what? It is the ratio of quantity of steam which is bleeded. Okay, quantity of steam which is bleeded to the, in the denominator, what should you have? Quantity of the steam entering the turbine to the quantity of steam entering the turbine. So if you divide these two, you will get the value of M. That is mass flow rates itself.
Sir, what is 2, sir? Bleeded. Quantity of steam bleeded. What did you say, sir? What is 2, sir? What is 2 called?
Which 2?
That's a 2 kg per second.
I have just given you an example, man, to understand.
No,
Make
sir,
you
I'm
understand.
asking that term, sir. In the sense, 10 kg is mass
second.
supply. So what is that? Mass
It is
leading
10 kg per second. It is mass flow rate. Here also kgs per second. Clear or not, Khalid?
Yes, sir.
Okay. So shall I give you one more example? Will you just see me? The value of M?
Yes, sir.
Okay, now, so the quantity of the steam entering the turbine is 50 kgs per second. Now, out of which 10 kgs per second is bleeded back to regeneration. Now, what is the value of M now?
0.2.
0.2.
Yes, sir.
Okay. Adil sir. Okay. Is that clear?
Yes, sir.
Yes, sir.
Okay. Good. Now, why we require the value of M? So there is one more concept. Whenever there is a problem on regeneration, you should always focus on this particular state, which is state number 6. Okay, what is that? It is the feed water heater state. Okay, so you should always focus on that particular state. So what exactly will you get? Okay, now let us try to understand and draw a diagram like this. Okay, now this is state number 6. For state number 6, what are the different steam incoming and outgoing? Getting my point? So I am getting m amount of steam from state 5, right, to the state number 6. Yes or no? Please do reply. This is important to be
Yes, sir.
understood. Okay, so that is what I have written here. I am getting m amount of steam from state 5. Next, I am getting 1 minus m amount of steam from state 7. Correct? Here, 1 minus m amount of steam from state 7. The same thing I have written here, 1 minus m amount of steam from state 7. Next, one quantity of steam is being ejected to state 4. The same thing, one quantity of steam I am ejecting to state 4 here. Clear? What is this flow diagram all about? Understood? Any doubts?
No, sir.
So from this flow diagram, what will you get? You can have an energy balance. How to make an energy balance? Very easy. Flow rate into enthalpy would be equal to 0. If it is approaching the state 6, it is positive. If it is going away from the state 6, it is negative. Simple. Now, so how do I write energy balance equation? Please do look at it. Okay, we will have practice of it. First come to this stage where m amount of fluid is coming from state 5. Correct? So I would write m cross h5. Now whether this is positive or negative. Whether this is positive or negative. This particular quantity is being approaching state 6 or it is going away from the state 6.
Approaching.
Approaching, then it is positive.
Positive.
Now, come to here, this particular line. Okay, here, how can I write the same thing as I've written previously? Now I want to write it here. Mass flow rate into 1 minus m amount of steam is coming from state 7. So it is, I'll be writing as H7. Okay, whether this is approaching state 6 or it is going away from the state 6.
Approaching.
Approaching in the sense whether it is positive or negative.
Positive.
The last one here. So similarly, mass flow rate into enthalpy. So here it is 1 into H4. Now this particular thing is going away or approaching state 6. Mohan. Whether it is approaching state 6 or it is going away from the state 6. Oi. Whether the Mohan is right? Whether Mohan is right. I am talking about state 4. Then what it is? Whether it is
Moving away from 6.
I guess it is going away, right? Nodi. Away ಹೋಗ್ತಾ ಇದ್ದಾನಾ ಅಥವಾ ವಾಪಸ್ ಬರ್ತಾ ಇದ್ದಾನಾ?
Away, sir.
So away ಬರ್ತಾ ಇದ್ರೆ ನೆಗೆಟಿವ್ ವಾ ಪಾಸಿಟಿವ್ ವಾ?
Negative.
So negative ಹಾಕಿದ್ದೇನೆ. So when I club all these contents, I would get an energy balance equation, which is this. Getting my point? Understood how do I get this particular equation?
Yes, sir.
Okay, good. So this is without neglecting the pump work. So if you don't consider the pump work, this is the thing what it is happening. Okay, if you consider the pump work. Suppose if you neglect the pump work, so where is pumping work happening in this particular TS diagram? Anyone? Where is the pumping work which is happening?
6, no, sir.
6 to 4 is one pumping work. And what about 3? 7 to 6?
7.
Okay, that is
3 to
also
7, sir.
okay. Even that is also a pumping work. So if that particular pumping work is being neglected, so what happens if there is no pumping work? Can I say H7 would be equal to H3 if the pumping work is not there? Can I say H1, H7 would be equal to H3? Because there is no, this pumping work length will be not there, no. There will be no pumping work. It would be 0. So if it is 0, then can I say H7 would be equal to H3? Yes or no, man?
Yes, sir.
So similarly, if I neglect this pumping work also, even this is also a pumping work, no? If I neglect this particular pumping work, okay, can I say, what can I say? Like H4 is equal to H6 if I neglect the pumping work from 4 to 6.
Yes, sir.
So if I neglect the pumping work from 3 to 7, so H3 would be equal to H7.
H4.
The same thing
H7.
I have written here. The same thing I have written here. Okay. Now what I will do is, if I neglect the pump work, what I have to do is I have to replace H7 with H3 and I have to replace H4 with H6. This particular equation I would get when I am neglecting the pump work. Is it clear? Is it clear? Any doubts?
No, sir.
Okay.
Please do copy this particular problem. I guess tomorrow you have class, right? ನಾಳೆ ಕ್ಲಾಸ್ ಇದೆನಾ ಇಟಿಡಿ?
Yes, sir.
Yes, sir. Affirmative, sir.